Hello everyone, welcome back to our channel once again. We believe that everyone should learn electronics and we make it easier through these tutorials. This channel covers DIY projects both for learners and professionals seeking to advance their knowledge on using various ICs and microcontrollers. In today's episode, we will explore how to cascade yet another versatile IC you can rely on, the CD4017. The first part of this video will enhance your understanding of the IC and how it works. That way, it will become easier when we finally cascade them to the number of outputs needed. CD4017 is a Johnson decade counter with 10 sequential outputs labeled from Q0 to Q9. These outputs turn on sequentially, one after the other whenever a clock pulse is received. From the video playing on your screen, the clock pulse comes from a 555 timer IC configured as an astable multi-vibrator. We have done a video about it and I will leave a link in the description for you. You can clearly see the LED on the right blinking while the ones arranged in rows turn on one after the other. The CD4017 is a CMOS-based IC but is compatible with TTL technology. So, you can easily and conveniently interface it in your digital circuits to achieve the intended function. This IC uses a wide voltage range, typically between 3.5 volts to 18 volts. However, you should confirm these values from the data sheet for the particular IC you are using. Some manufacturers make their to use a maximum of 15 volts. The CD4017 counter IC comes as a dual inline package chip with 16 pins as shown on the screen. Pin 8 is connected to the ground and pin 16 is the VCC pin connected to the positive rail of a DC power source. Pin 15 is the reset pin. When it goes high, the counter is reset to 0 and the IC starts counting again. Usually, this pin is connected to the ground to allow the IC loop over all its 10 sequential outputs. Pin 14 is the clock input pin. This is where you provide the clock pulses. In this case, square waves from 555 timer IC. The IC's output changes with the rising edge of the clock. Pin 13 is the clock enable pin. This is connected to the ground to allow the IC accept the clock pulses and change the states of the respective output pins. You set this pin high if you want to disable the IC at any stage of the operation. The rest pins are the 10 output pins Q0 to Q9 as shown on the screen. We have also done an LED chaser or running light circuit using the CD4017 IC. You can check both parts A and B, link in the description to learn more. In today's project, we are going to construct a simple LED chaser to explore the functions of various pins. This knowledge will be handy when finally cascading the CD4017s or when designing various projects. We will use the following components: CD4017 IC, 11 LEDs, 330 ohm resistors, breadboard, DC power source, jumper wires. Clock pulse generator will be provided by 555 timer IC. Let's build the circuit. Place the 555 timer IC on the breadboard as shown. Connect a 220 ohm resistor between pin 8 and pin 7. Connect 1K ohm resistor between pin 7 and pin 6. Connect pin 8 to the positive VCC and pin 1 to ground. Short pin 4 to pin 8. Short pin 6 to pin 2. Place 470 microfarads capacitor between pin 2 and the ground. The clock signal generator is now ready. Let's test it. Connect 330 ohm resistor from output pin 3 to LED and to the ground rail or negative power supply terminal. Observe the polarity of the LED. The longer terminal is always positive and the other negative. And it is working perfectly. Place the CD4017 IC on the breadboard as shown. The notch is facing the left side. Connect pin 8 to the ground and pin 16 to the power rail. Connect pin 14 to the clock signal generator. Connect pins 15 and 13 to the ground. This enables both clock and allows the IC to loop over all its outputs. Place 10 LEDs on the breadboard as shown. All the negative terminals are shorted together and then connected to the ground through a 330 ohm resistor. Connect the first output, pin 3, to the first LED on the left. Do the same for the second output until the last LED is connected to the last output. Use the image on your screen as reference. Power the board and observe the CD4017 in action. What we have built is a simple LED chaser that is able to loop over all the 10 LEDs. You can make it faster or slower by simply adjusting the frequency of the clock pulse. Once again, we have covered that in our previous video, link in the description. Now, let's verify what we learned in theory about pins 15, 13, and 12. Currently, both pins 13 and 15 are connected to the ground. Connecting pin 15 to any of the outputs will make the counter counts only up to that input and start again from 0. This is helpful when you don't need all the 10 outputs. Maybe you want to count up to 7 and repeat again. Simply connect the 8th output to pin 15 and it will do as you please. As mentioned, the reset pin resets the IC when the pin is driven hot. Let's connect pin 15 to the ground through a 330 ohm resistor instead of the direct connection we had earlier. Now connect the pin to positive power rail. Noticeable, the counter stops at that point with its last state maintained. Also as mentioned, pin 13 is the clock enabled pin. You can drive it high at any time to hold the IC whenever you want. The CD4017 IC ignores any incoming clock pulses as long as its clock enabled pin is set high. It will only resume once the pin goes low again. Lastly, let's talk about pin 12. This is called the carry-out pin. Connect the positive lead of an LED to this pin and the other lead to the ground through a 330 ohm resistor and power the board. Noticeably, this pin remains high for the first half of the cycle and goes low during the last half. It seems useless at the moment, but we will show you how you can use it in our next projects. That is the end of this part A of cascading the CD4017 IC. We will use this knowledge to finally cascade 3 ICs to have up to 25 outputs. It will be a bigger LED chaser than what we have seen already. See you there. Kindly subscribe to our channel and leave us a comment. Your little support goes a long way to ensure we constantly produce such contents to meet your needs and our other viewers just like you. Thank you and have a good day.